Welcome! In this series of videos we will look at topics common to both the PowerBasic Console and Windows compilers. Today we will look at the definition and use of arrays. A one-dimensional array can be thought of as a list of values referenced by row number. By default, arrays are created with a 0 row, but you can override this easily if needed. To reference an element of the single-dimensional array, we merely need to use the array name and the row number in brackets. This row number can either be a literal number or can be stored within a variable. Updating any element of this array can be done by using the name of the array with the element or row number in brackets, then an equal sign and the literal string enclosed in double quotes. Naturally, the element can be referenced by a variable and also be updated with the contents of a variable. In two-dimensional arrays, we have both rows and columns and need to specify both numbers to reference the data held within the array. Updating of this multi-dimensional array also requires both row and column numbers to reference the data to be updated. For numeric arrays, the approach is the same, the only difference being that the data going into the array does not need to be enclosed in double quotes. As there are a number of different types of numeric variable, there can also be different types of numeric array. For numeric arrays beyond 2 dimensions, the approach is exactly the same, the only difference being using a third element to define where to store or to get the value. Memory permitting, you can even go beyond 3 dimensions should you find the need to do so. In this series of videos, we'll be covering topics which are common to both the PowerBasic Windows compiler and the PowerBasic Console compiler. In order to do this, I've set up a small common library to allow us to display information on the screen from a program regardless of whether you're using the Windows or the Console compiler. There are 3 basic functions in this common display library. There's prep output, log, and wait. The prepare output function takes a console name as a parameter, an X and a Y start coordinates, and optional rows and columns. Since this code is designed to work regardless of whether you have the console or the Windows compiler, we're using a conditional if statement, which is handled at compile time, to test if we're actually inside the console compiler or not. So you'll see in here there's an if def pbcc32, which if that's set up we are in the console compiler, and it will prepare the functions accordingly. If we're in the Windows compiler, the same 3 functions will be prepared, but internally they'll be slightly different. So for the console compiler, we're using a standard console window, and for the Windows compiler, we're using a text window. Arrays, like any variable, can be either declared locally within a subroutine or function, or they can be declared globally. What we're going to do here is to declare a local numeric array. The dim command is used to dimension your array. You then have the name of the array, the number of elements within the array, and the type of variable stored within the array. In this case, we're storing 10 values, which are all long variables. To set the value of any element within the array, you merely need to put the name of the array in, the element you wish to store, and the value. If we print that out, as the array is a numeric array, we're using the format command to turn it back into a string. And if we run that now, we get the value 10 being output to our console. Now what we've done in declaring this array is effectively this. It defaults to having a 0 element. If you do not wish to have a 0 element, then you can quite happily do 1 to 10, in which case there will be no 0 element. If we wished to create a string array, we can do so like this. And there's a value stored. Also, when you're putting information into an array, it doesn't have to be a literal string or a literal number. It can indeed be a variable. Putting the value into the array doesn't have to be a literal number. It can indeed be a variable. And you would update your array by merely putting in the name of the variable. And if we run this now, there's a value coming out quite happily. The element of the array can also be a variable. Like so. Arrays, since they exist in memory, do operate very quickly and can be used very powerfully. If you have a look at the help, go to the index and type an array. There are a number of things you can actually do with the array. You can sort arrays, you can insert values into arrays that already exist, both string and numeric, or you can delete information from an array to remove an entire row. And the other commands you will find very useful for arrays. The erase command can be used to erase information completely from arrays, freeing up any memory. And there is also the redim and reset commands. If you wished to extend an array, for example, our numeric array here was 10 elements. You may find that in some of your code you may want to set off with a value that's quite small and then redimension it during the running of the code. The redimming command, as it stands, will effectively increase the size of that array to whatever you specify. Now, using the command this way would mean that any data within the array would be erased. If you wish to preserve it, you can use the preserve command, which would mean that the data we'd already put into the array, i.e. this value here, would still exist, but there would be in addition 10 more elements in the array. Arrays give you very powerful ways of actually doing things, and you can set arrays up for any of the types, as in so. You're now storing a double precision value within an array. This is a small introduction to arrays. Thank you for watching.